Hi, this is a video about R. This is meant for students that perhaps are not that familiar with R. If you already know how to program with it, then don't worry about this video, just keep it all together. Basically what I did is I went ahead and downloaded one of the examples that was described in your context. It's the Cleveland data. So you look at this, it's just a comma separated file. I have it on my path. This is my path, and I just then invoke R just by saying R. And now that I'm here, I can just create a data set by importing that file I downloaded, and for that I just use this. It's called read.table, and I just give it the name of the data set. One sec. Then give the name of the data set, and I have to tell it it's a comma separated file by using sep equals comma, and I have to tell it there is no header by saying header equals false. Then now you're done. You have your data in. It's all you have to do to bring the data. So if you just go ahead and say data, it prints everything out. If you notice, you have a bunch of columns. They're all numeric, and if the R has something very cool. It's called subsetting, and you can subset that data. So you can say data, open brackets, say 1 to 5. This will show me only rows 1 to 5, and if I only want to bring for all, so if you notice, every one of these, as I didn't have a header, is called a vector. So it's a numeric, one of those is a numeric vector. But if let's say I only wanted also only 1 to 4 of the columns, so now this I can subset it like that. So now I have only the first 5 rows and only the first 4 columns. But let's say that now I wanna get something, let's say the mean. I could get the mean. Since these are all numeric vectors, I could say data big one, and that's how I call that vector, and it gives me the mean for the first vector. That will work for all of them. It could also work, you could also call a standard deviation. It's just calling a function. So to call a function, just mean, you give it the vector, and that's it. Like for example, mean data b5, right? And so that's very useful. Then subsetting allows you to manipulate your data as well. And another thing that is very important that may be useful for you as well is you can create a matrix. So let's call test, and you can say matrix. You can create this matrix, a matrix of zeros, and let's have a matrix of 2 columns. So say in column 2 and row 2 as well. So this creates a matrix that has 2 rows and 2 columns, and that also you can actually then call test by the indices. So you use I and J. So row 1 and column 1, and you can assign a value to it. So if you say now test, I just assign the value for the 1 row 1 column, and I assign the value, and I now have it on my matrix. So that may be useful. And turns out that you can also install a package called Biostrings. And to install a package, that package, you can actually do it by calling the following commands. You can actually do this. If you say source this bioconductor.arc / bioxig arc, it installs something called biolite, and then you say biolite biostrings. That then loads the library called biostrings, and if I call biostrings, now I have that library installed for R. And it's very interesting, very useful, because then you can go ahead and do something like create a biostring, and for that you do the following. You can say DNA 1 is DNA string and that's, so if I call DNA1, now I have that biostring. And also you can actually go ahead and call something, call a function called dinucleotides. So in that DNA string that I just created, I can call the function dinucleotide frequency, and T1 is the nucleotide frequency. It gives you the frequency first. Hopefully you see the usefulness on this for calculating the frequencies of dinucleotides in a Markov chain of degree 1, of course, right? And not only that, but you could, for example, take this and say, take data.frame, make this table that I just got and convert it into data frame. And if I go for data 2, you see now I have like a nice table, and I could actually go to T2 and say, give me all the count for AA, and there it goes. How about the count for CT, let's say, and there it is. So as you can tell, probably this is all you need to calculate the dinucleotide frequencies in R, and it's probably the bulk of what you need for your homework. Again, I hope this video is useful. Give me some feedback. If you feel that there is a particular thing in R that you would like to get addressed, let me know, and hopefully this works. Thank you. To quit, you just say quit and just thank you.